Welcome to another deep dive into the world of LLMs. We're focusing on aligning them this time. You've sent over a couple of research papers, and well, they're really fascinating. We're going to explore what they could mean for AI researchers and engineers, especially.
Aligning these LLMs is becoming more and more important, as they
Mhm.
get more powerful and we use them for more things.
Yeah, you're right. It's like we're trying to make sure that all this power that we're putting in these LLMs is actually used for good, that it's safe for everyone. So the first paper we'll look at focuses on a new method. It's called FPO. That's a feature-level constrained preference optimization. But to get into FPO, we should probably do a quick recap of DPO first. Can you give us that overview?
Sure, direct preference optimization, or DPO, is a way to train these LLMs directly using feedback from us humans. Like, say you have a couple of different responses from an LLM. With DPO, you just tell the model which one you like better, and then it learns from that direct comparison, right? So it helps shape the model's behavior to be more what we want without having to use those complicated reward models.
So it's all about making the LLM understand what we think is a good response, basically. But like anything in AI, there are always trade-offs. What are some of the challenges researchers are running into when they actually try to use DPO?
Yeah, so there are definitely some challenges. One of the big ones is that DPO can be really computationally expensive, especially with these massive LLMs that we have now. And it also sometimes doesn't give you the fine-grained control that you might want over the model's outputs. For example, like, you might like the sentiment of a response overall, but want to change a couple words here and
I
there.
see. And that's where this FPO comes in, right? Trying to fix those DPO limitations.
Yeah.
So what's different about FPO?
Well, FPO takes a more focused approach. So rather than trying to control everything the LLM spits out, it focuses on the most important information, the stuff that it actually uses to make decisions. It's kind of like, instead of trying to shape an entire mountain, you just focus on the biggest peaks and valleys.
Yeah,
You let the finer details just happen naturally.
that's a good analogy.
Yeah.
So how does FPO figure out what the peaks and valleys are? What's the most important info for the model to make a decision?
Well, it uses something called sparse autoencoders,
Yeah.
SAEs. These SAEs are like really smart filters. They go through all the data the LLM processes and pick out the important features that influence the responses it gives. So it helps us hone in on just the crucial stuff without getting lost in all the noise.
Okay, now I need some specific examples here. The paper mentioned some pretty impressive results with FPO. You got any details that would make our listeners, these AI researchers and engineers, go, wow?
Oh, yeah, for sure. So in one of the experiments, they were working with a model that had something like 16,000 features. That's a lot. But with these SAEs, FPO only had to worry about a few dozen to get big improvements. So way less complexity, way less computation.
So it not only saves computing power, but it also gives researchers more precise control over what the model does.
Yeah, exactly. Like, you're finding the exact levers you need to pull to get what you want without having to mess with everything else.
That's amazing. And the paper also mentioned that FPO doesn't even need the full reference model loaded during training. It uses information from a cached version,
Yeah.
so that's even less computation needed, right?
Right. And it gets some impressive results too. Like, it beats other methods on a bunch of benchmarks. Like, there's AlphaKaival 2, which measures how well it follows instructions, and there's MTBench, which looks at machine translation. FPO beats them, sometimes by over 5%, which is a lot.
So if someone is out there listening to us, deep in the AI trenches, what does this all mean for them?
Basically, FPO is a new tool for aligning LLMs that's more efficient and gives you more control. So it's great for people working in smaller teams, people with limited resources. This could make aligning these powerful models much more accessible. And that could really change things in the AI landscape for the better.
I think that's the big takeaway here. It's not just about making the LLMs better. It's about giving everyone a chance to shape these powerful tools, which, in the end, will lead to a much better, more innovative AI landscape.
So we've talked about how to make the alignment process more efficient, but what about something even more groundbreaking? The idea that LLMs can actually learn and improve all by themselves.
That's where it gets kind of sci-fi, right? Like these LLMs becoming their own teachers is both amazing and maybe a little scary. What's this second paper all about? What were the researchers trying to figure out?
They were looking at a big question in AI. Can we make an LLM better at reasoning over long chunks of text without humans stepping in? Or even more powerful AIs. Can these models just bootstrap their own learning and get smarter on their own?
So it's not just us teaching AIs, it's AIs teaching themselves. What did they find out?
It's pretty remarkable, actually. They found that LLMs have way more reasoning power than we thought. Like, they have the knowledge, but need better strategies to actually use it. especially with those tough tasks that need understanding and reasoning over long stretches of text.
It's like when you know you have some information stored away in your brain but can't quite access it. Like it's in there somewhere. How did they unlock that potential in LLMs?
One of the key things was prompting, believe it or not. They tried different ways of prompting the LLM and found that a plan and solve method worked really well. It's like giving the LLM a problem and then telling it to first break the problem down into smaller steps before trying to solve it.
So giving the LLM a way to organize its thoughts, a framework to approach the problem.
Exactly. And that's where this oracle concept comes in. They had the LLM come up with multiple answers to the same question, and guess what? Even if the first response was so-so, at least one of the other answers was usually way better.
Oh, it's like the right answer was in there somewhere. The LLM just needs some encouragement to find it. How do we make it consistently come up with the good stuff?
That's where C-long comes in. It's a self-improving method designed for long context reasoning. 2 stages. First, the LLM generates a bunch of different outputs for the same question, exploring different paths. Then, using something called minimum Bayes risk, they pick the best ones.
Hold on. Minimum Bayes risk. Can you break that down a little bit for our listeners?
Sure, it's basically a way to make decisions when you're not totally sure about things. In this case, it helps pick which of those LLM outputs are most likely to be right. Like, imagine you're getting advice from a bunch of experts. If most of them agree on something, you're probably going to trust that more than if just one expert says it.
Makes sense. So Long finds those expert answers from the LLM itself. What happens next?
Then it uses those good answers to fine-tune the LLM, either through supervised learning, where the best answer is treated as the correct one, or through preference optimization, where both good and bad answers are used to help the model learn.
So the LLM is basically learning from itself, getting better based on the times it actually nails it. That's pretty cool. But did it actually work? Did they see improvement?
Oh yeah, for sure. They tested C-long on different LLMs and got some impressive results, way better than other state-of-the-art methods, even some that use data from much bigger models like GPT-4. Like one model, Llama 3.18b Instruct, got a 4.2-point improvement, which is a lot.
That's incredible. So it's not just a theory. Long actually makes these LLMs better at reasoning. And it seems to work across different sizes of LLMs too, right? Even smaller ones.
Yep. So we might not always need those massive resource-heavy models to get really good reasoning capabilities. Opens up a lot of possibilities for researchers working with less powerful systems.
So this is kind of a big deal for AI research, right? It's challenging how we think about building these intelligent systems.
It really is. We might be underestimating the potential of these LLMs to learn on their own. C-long shows us a way to build AI where the models can learn by themselves and get better with less help from us.
That's a pretty big paradigm shift. If we can actually tap into this self-improvement, we could speed up AI advancements in so many fields.
But there are also some risks here, right? LLMs doing their own thing could lead to unintended consequences.
Yeah, absolutely. It's like we're at this point where LLMs are going from tools that we build to things that can participate in their own evolution.
It's both exciting and kind of unnerving. It raises a lot of big questions, for sure. This self-improvement thing with LLMs, like we see with C-long, it's a whole new area of AI research. We could see some crazy breakthroughs in areas like natural language understanding, reasoning, all sorts of problem solving, but
There are probably a lot of risks too, right? Like giving these LLMs so much freedom could lead to problems. What are some things researchers should watch out for as they explore these self-improving capabilities?
control is a big one. As these LLMs get better at learning and adapting on their own, we have to make sure they're still aligned with our goals and values, right? We need ways to steer their development and prevent unintended consequences. It's like setting boundaries for a student who's super eager to learn, but needs guidance to make sure they're learning the right things.
So it's about encouraging those LLMs to learn and grow, but still keeping them on the right track, especially since they learn so fast.
Exactly. And another thing to think about is bias. You know, LLMs learn from the data we feed them. And if that data has biases in it, well, the model could end up amplifying those biases as it improves itself. And that's not good. We need to find ways to reduce bias, both in the data and in that self-improvement process. We want these models to get smarter in a way that benefits everyone.
So it's not just about intelligence. It's about building LLMs that are both smart and fair. So before we wrap up, what are the key takeaways you'd like our listeners to remember?
We started off talking about FPO, It makes aligning LLMs more efficient and gives us more control. It also makes it easier for more researchers and developers to work on aligning these models. Then we looked at CLong, which shows that LLMs can potentially learn and improve themselves, especially with reasoning over long chunks of text. Both of these papers really highlight the future of AI, where models are becoming more capable and independent. But they also remind us that we need to be careful. We need to develop AI responsibly and ethically.
Yeah, those are definitely some big ideas to chew on. Any final thoughts for our listeners as they continue their work in AI?
The future of AI depends on the choices we make today. It's our responsibility to make sure these advances in AI lead to a better world for everyone.
That's a great point to end on. Thanks for joining us on this deep dive into aligning large language models. Keep exploring and innovating, and don't forget the importance of ethical AI development.